Today's lesson is lesson number 3 in transformations, and your I can for today is I can rotate an image about the origin. We're always going to be rotating around the origin or the point 0, 0. In this unit. In the future, you may rotate around a different point, but not today. The first problem is just a review, and it says, write a rule for the reflection in coordinate notation. Remember, coordinate notation is we take our original points and how we change them. So the first thing we have to do is figure out where did it reflect. Remember, the original image is just the letters. The new image is going to be prime notation. So my original is the pink highlight and my new is in blue. And then we have to think about how did it rotate, or how did it reflect, sorry. It reflected across your y-axis. So we know it reflected across the y-axis. And if you don't remember what the rule is, you can always think about this logically. So let's look at 2 points. F is at the point 4, 1. F prime is at the point negative 4, 1. G is at the point 2, 2. G prime is at the point negative 2, 2. And X is at 3, 3. X prime is negative 3, 3. We can simply look at these new points and look at our relationship. I noticed that in each of these cases, my X became an opposite. So the rule for reflecting across the x-axis is my X is going to become the opposite of what it was, but Y stays the same. So without even using notes and just writing out the points again, we can figure out the relationship in coordinate notation. Here, the first thing you notice is we have a clock, because when we talk about rotations, we have 2 different directions we can rotate. The first way is if we go in orange around with the numbers going lower to higher, that is clockwise. We'll represent clockwise with CW. If we go the other way, so in the pink, if we rotate the other direction around our clock, it's called counterclockwise. And we note that using CCW. And the beauty is counterclockwise and clockwise actually are related. So if we rotate 0 degrees counterclockwise, it would be the same as 180, it'd be all the way around our circle. So it'd be the same as 360 degrees around the other way. If we rotate 90 degrees counterclockwise, it would be 3/4 of the way around, which is 270 degrees. And when I'm talking about degrees, I'm talking about those quadrants. So imagine this is our coordinate plane. And if we start in quadrant 1, how many quadrants around? 90 degrees counterclockwise would be 1 coordinate over. But if we went clockwise, it would turn 3 to get to the same spot. So 180 degrees counterclockwise, so that's 2 over, would also be 180 degrees clockwise. 270 degrees counterclockwise is 90 degrees clockwise. And 360 degrees counterclockwise, which is all the way around, is 0 degrees when we go clockwise. So we're talking about which quadrant we're going to end up in. Quadrant 1, 2, 3, or 4, and how many degrees of a rotation that is. For each of these rotations, we have different rules to follow. I personally find that knowing the rule first and then seeing it in action makes it a little easier to understand. With all of these rules, it's remember in that coordinate notation. So if we start with the point x, y, how is it going to change? And it's very simple. If we rotate 0 degrees, it's not going to change at all. So it will stay x, y. When we rotate 90 degrees counterclockwise, my rule is it's opposite of y, x. So notice not only do my x and y numbers flip location, but y will also become opposite in that case. For a 180-degree rotation either way, it's very simple. Your x's will become opposite, y will become opposite. For a 270 degrees counterclockwise rotation, we still are going to flip my x and my y, but now instead of y becoming opposite, like at the 90, x becomes opposite. And 360 is all the way around, so we're right back to where we started, so it's back to x, y. I really think it helped personally. Knowing the rule first helps me understand rotations more thoroughly. To see a rotation in action, here's our first example. It says rotate 90 degrees clockwise about the origin. Anytime we talk about rotations, we have to be specific about clockwise or counterclockwise, so which direction. Remember, clockwise goes around our clock, and 90 degrees clockwise is going to be the same as 270 degrees counterclockwise. In order to see this, it's easiest to start with naming our original points. Point A is at -1, 2. B is at -4, 2. And C is at -4, 4. And so 90 degrees clockwise means we're going to go one quadrant around in the clockwise direction. And so what we have to do is we have to take this triangle and we have to rotate it around our origin into this next quadrant. And this is why I think personally it's easiest to know the rule. We know in coordinate notation, 90 degrees clockwise, what will happen is we are going to have y opposite of x. So if we think about what this looks like, A is going to rotate over to this point here, and it will become A prime. Notice A prime is at the point 2, 1. My x and my y flipped locations, and then my y, or my x value, became opposite. And we're going to do this with all of our points. B, if you can't see where it would rotate, we can look at it mathematically with the rule. I know it's going to become the point 2, 4. 2, 4 is B prime, and C prime is at the point 4, 4. When we reconnect the shape, here's a couple things to remember about rotations. First of all, it should make the exact same shape. Exact same shape. We haven't changed anything about it. All we did was turn it around our origin. And so when I look at this, it's the same shape, same size, same number of units between my 2 points. Between B and C, I have 2 units. Between B prime, C prime, I still have 2 units. So making sure that nothing about the shape has changed except for its directionality. That's something else to remember when you're rotating. Next, we're doing a 180-degree clockwise rotation. 180 degrees is 2 units, or 2 quadrants around, which is going to be the same 180 degrees counterclockwise. So it's the same amount whether you're going clockwise or counterclockwise. I know if I go 180 degrees clockwise, if I'm in quadrant 1, clockwise is going around. I'm going to end up way over here in quadrant 3. This is my clockwise rotation. Counterclockwise, if you want to see what that was, quadrant 1, going the other direction into quadrant 3. This is counterclockwise. Remember to specify which way you're going. So to start, let's find A, B, and C. A is at the point 1, 2. B is at the point 1, 4. And C is at the point 4, 2. So if we think about taking this image and flipping it around the origin, we're going to swing it around the origin over into quadrant 3. I know A prime should end up here. And it's kind of upside down now. C prime, and keeping that shape the same, B prime. A, B, C prime. I swung it around my origin. Now, if you can't see where that ends up, let's use the rule. Coordinate notation says we are going to take the points x, y, and all we're going to do is opposite of x, opposite of y. So A prime is -1, -2, B prime is -1, -4, and C prime is -4, -2. And let's double check to make sure we have that right. A prime, -1. Oh, my triangle's off. So let's think about how we can fix this. So erase my original because I did that wrong, and let's redraw it using our points. That's why we always have 2 different ways of doing this. A prime is at -1, -2. I didn't go quite down far enough, so I had my points wrong. B prime is -1, -4, B prime. C prime is -4, -2. So I relabeled, I redrew, and it is in the correct shape this time. My old one was up a level too high, but that would make it wrong. So now that we had those points to double check with, I know I rotated my triangle properly. And last, we have a 270-degree clockwise rotation. We know is going to be the same as a 90-degree counterclockwise. So when we think about picturing this, 270 degrees clockwise, we're going to start in one quadrant and go to 3 quadrants over. This is my clockwise 270. And if we go counterclockwise, it's simply over 1 unit or 1 quadrant, counterclockwise. So thinking about how this is going to look, let's start by finding our original points. A is at the point -4, -3. B is -4, -1. And C is -1, -3. Now, if you can visualize how this is going to look, wonderful. If you can't, remember we always have that rule. X, Y, 270 degrees clockwise. What happens to my points? I know it becomes opposite of Y, X. So C is going to swing up to here. Here is going to be my C prime. If you can see that, and I'm actually looking at this as a 90 degrees counterclockwise to see it a little more visually for me, great. If you can't see that, that's fine. Use your rule. And then here is going to be my A prime and B prime. So I did this visually, taking my original triangle and rotating it 90 degrees counterclockwise. But I want to make sure I double check my points because in the last slide, remember, I made a mistake. So using the rule, A should end up at 3, -4. So A prime is at 3, -4. I did A prime correctly, so let's make sure the rest of my points are correct. B prime should be at 1, -4. B prime, yep, that one's right. And C prime should be at 3, -1. 3, -1. C prime's correct. So this time I was able to swing it around or rotate it visually, and I double checked using that coordinate notation rule that we have here, and I made sure that I did it correctly. So in review, a few things just to remember is that it's helpful to make sure that you know counterclockwise versus clockwise rotations, and then using these rules to help you understand things more thoroughly.